Hello friends, welcome to the next section, writing data to SQLite and schedulers. We'll begin this section by learning about the types of schedulers. Then we'll learn to use schedulers, and lastly, we'll be writing data using store.io. Now we move on to the first video of this section that deals with types of schedulers. There are a few types of schedulers, and each of them is intended for a different type of work. Here in this video, we'll cover all of them. The first type of scheduler that we'll learn about is single. The single scheduler can be created by calling schedulers.single method. It's backed by a single thread, so it means that the code will always be executed only on that one thread. Consider this as a replacement for your main thread if there's a need for that. In general, there'll be very few cases when you'll want to use it. Next scheduler is Trampoline. Trampoline is a scheduler that executes code on the current thread. It adds a code block that will be executed to a queue of the current thread. If on.observeOn and .subscribeOn is used, it doesn't change the default behavior of the observable, and thus it is basically a no operation, NOOP. It's mostly reserved for advanced use when creating custom observables. An example where Trampoline could be used is to help avoid Stack Overflow exceptions when calling recursive code. Finally, if there is really a need for it, and a developer knows it's something that he really needs, it can be created with a call to schedulers.trampoline method. Next scheduler is newThread. NewThread is a scheduler that's created by calling schedulers.newThread method. Basically, newThread can be used anywhere whenever there is a need to offload computation from the current main thread. However, creating a new thread for each observable can be costly in the long run, as thread creation is a relatively heavyweight operation, and there are other schedulers that might be better suited for computation offloading. One thing to keep in mind is that this scheduler doesn't place any limits on the number of threads that will be created. This might not be a problem for observables that are created rarely and emit just a few items, but if there will be cases when 1,000 observables are created, it means that there will be 1,000 threads. It's something that's best avoided by using other types of schedulers. Next, we'll learn about I/O scheduler. I/O is the most often used scheduler. It can be created by calling subscribers.io method, and it's perfect for I/O-related workloads, such as network requests, accessing the file system, or content resolvers on Android. The I/O scheduler is backed by a worker pool. Initially, the pool starts with one worker, and it's reused between different observables when available. However, if there are no workers left in the pool, a new worker is created. After the worker finishes its current execution, it becomes available once again for the next execution, so the system can save resources by reusing workers instead of recreating them each time. The size of a pool is unbounded, so care must be taken when there is a chance that an unbounded, or a very large, amount of observables will be created. However, the unused workers are removed after 60 seconds so that the pool size can shrink down after a while. In general, it's a very handy and robust scheduler, so it can be used in almost all cases where I/O operations are involved. Next scheduler is computation. The computation scheduler is similar to the I/O scheduler in that they're both backed by a worker pool. However, the size of the computation scheduler's pool is fixed to the number of cores available in the system. Since the amount of available workers is fixed, it means that there are more jobs to run than the amount of processors. They will have to wait until a worker becomes available again. Since this scheduler is sensitive to running out of workers, as there are only a few of them, it would be a poor fit for I/O-based tasks, and especially for network requests. For example, if there are only 2 workers available, which is quite often the case on phones, it will only take 2 requests to exhaust the pool. If the request takes 3 seconds to complete, it means that the scheduler won't be able to do anything else for at least 3 seconds, and everything else that uses the computation scheduler will be put to halt. However, it's a great fit for calculations that need to be done off the main thread and are relatively quick to be completed. This includes event loops or buses, UI event handling, doing relatively complex math calculations, and similar kinds of work. One of the last schedulers that we'll cover is the Executor Schedule. It was created to consume a custom pool created with an executors class from the java.util.concurrent package. This is the code to do it. Then it's just a matter of passing and using it in .subscribeOn. This scheduler can be used to create bounded worker pools that can replace I/O scheduler in cases where the chance of creating lots of observables is quite likely. The last scheduler that we'll cover is the Android scheduler from the RX Android library. It's nothing new as we've already used it by calling this line of code. Its purpose is to return the execution of the code to the main thread of Android. It must always be used in cases where the computation was offloaded to some other scheduler, and the result was returned must be shown in UI. As we already know, no UI modifications can be done on threads other than on the main Android thread. In almost all cases, it will be used in .observeOn calls, as usually the main place where the UI modifications are handled are the .subscribe blocks. This brings us to the end of this video. Here we learned about the types of schedulers.